Okay, we're going to do a problem about oscillations and energy. Oscillations and energy. So what do we have here? So we have an oscillator. Here it is. We have a little system here where we have a particle, and let's call it a particle with mass m. And you have a spring here, which is going to pull this way. It's going to pull to the left. And if you push this particle, if you take it over here to this point over here, you have displaced it, and then you have it, well, you have a displacement. So your displacement is going to be all this distance right here. And that's going to be your amplitude. This is going to be your amplitude. And then you're going to hold it here before you let it go, because once you let it go, it's going to start to oscillate back and forth. And when you hold it here at this point, let's call it x final. And this one is going to be x sub naught, which is the point of equilibrium. When you take it all the way to x final, which is the point where you're going to hold your particle before you let it go, and the velocity is going to be 0 at that point. And the amplitude is going to be, okay, let's put the amplitude. The amplitude is going to be delta x, which is going to be x final minus x initial. And let's do x final equal to 0.5 meters. So that's your x final. Okay, so what do we want here? Well, we want the total energy. Let's put it over here. So we want the total energy of this mass spring system. It's a mechanical system. And we also want the velocity when the particle passes at the equilibrium point. So what is the velocity when it goes through the equilibrium point? The equilibrium point is going to be x sub naught. So we want that velocity. And we want the velocity when it passes through a point halfway of the amplitude. So halfway of the amplitude, we want to know what the velocity is going to be at that point. Okay, so that point would be this one right here. This point here in the red, this red point. This is the point A divided by 2. And we are going to calculate the velocity at that point too. So let's do all this. So the total energy of our system is going to be the kinetic energy plus the potential energy. Kinetic energy plus potential energy gives you the total energy of your mass spring system. Okay, so the total energy is going to be equal to 1/2 of the mass, and the velocity is going to be 0 because you're still holding this particle and you're not letting it go. And you have given the particle all the amplitude possible, which is 0.5 meters, plus 1/2 of kx to the square. Let me put it over here again here. It's going to be 1/2 of the mass velocity to the square plus 1/2 of k x to the square. This would be the general formula right here. It's kinetic energy plus potential energy of the spring, and the potential energy of the spring is 1/2k x to the square. That's the potential energy. And this one here is the kinetic energy. There we go. This is the kinetic energy. 1/2 of the mass velocity to the square gives you your kinetic energy. And 1/2k x to the square gives your potential energy. So this term is going to go to 0. So the total energy of your system here is going to be 1/2. And let's give values to this. I'll put it over here. Let's say that K is equal to 120 Newton over meter. And let's say that the mass of this particle is 2 kilograms. 2 kilograms is the mass. So what do we have? We have here, okay, a Newton over a meter over here. So what do we have? We have 1/2 of K. What is K? K is 120 Newton over meter, okay? And times 1/2 meters, and this has to be elevated to the square because x sub naught is 0.5, which is 1/2 meters over here. So So we got that the total energy is going to be equal to, this is going to be 60 Newton over meter. Okay. And you're going to multiply that times 1/4 meters to the square. Okay. Meters to the square. So your total energy is total energy is going to be equal to 60 divided by 4. And then this meters to the square cancels with this meter over here, and you got Newton times meter. And that's going to give you 15 joules. 15 joules is going to be your total energy. So you got the first part. So the total energy is going to be 15 joules. That's your total energy right here. Okay, let's calculate the velocity when you pass through a point x of naught. That means at the when you pass through a point at the equilibrium point. Okay, so let's do it over here. So the total energy, we're going to use our equation again. We're going to use our energy equation again. So the total energy is going to be 1/2 of the mass velocity to the square, which is the kinetic energy, plus 1/2 of kx to the square. But when you pass through the equilibrium point, x of naught is going to be equal to 0. That x is going to be equal to 0. So this term is going to go away because this x is going to be 0. X here is going to be 0. So you get rid of the x. But the total energy, we know that's 15 joules. And that's equal to 1/2 of the mass. And the mass is 2 kilograms. And we want the velocity when the velocity at the equilibrium point of x of naught at x of naught. That's what we want. So we can say here that this is going to be 2 times 15 joules divided by 2 kilograms, and you got to get the square root of all that, and that's going to give you your velocity at x of naught. And this 2 is going to cancel with this 2, and this is going to be the square root of 15 times meter over second. If you do the math, this is what you're going to get. So you're going to get your velocity at x of naught. So we got that one too. So that's going to be the square root of 15 meters over second. And you got another one right there. And let's do the last one, which is the velocity when you pass through a point at the middle of the amplitude, because the amplitude is going to be a displacement, is going to be a distance. And you're going to pass through the middle point, which is a divided by 2 right there, this one right here. Okay, so we have a formula that we could use to calculate the velocity at any point. So we want to calculate the velocity at any point. So the velocity at x, which is could be any point, is going to be k divided by m. It's going to be a to the square minus x to the square, and then you got to get the square root of all this. So that's going to be equal to 120 Newton over meter over 2 kilograms, which is the mass. And it's going to be a is going to be 1/2. And you got to square that, 1/2 to the square. Minus, okay, minus, okay, let me make it a little better here. So it's going to be, this way. It's going to be here. Let me make it bigger here. So it's going to be a to the square minus a over 2. And I'll do a little bracket here to the square. And I got to get the square root of all this. So what is that? So that's going to be 60 Newton meter over kilogram. Newton over meter over kilogram, 60. And here you're going to have a to the square is going to be a to the square minus a to the square over 4 right there. And this is going to be 4 divided by 4. And then you're going to get the square root of all this. Okay. And that's going to be equal to 60. And 4 divided by 4 minus 1 divided by 4 is going to be, I'll put it in here. It's going to be 3 over 4. A to the square. And then you got to get the square root of all this. Okay. So let's do it over here. So this is going to be equal to, this is the velocity at any x at any point. So this is going to be, you can pull out the a out of the square root. And then you have this one, which is going to be, okay, it's going to be 180 divided by 4. That's what you got inside. And what are the units? Well, 60. The units here are Newton over meter. Newton over meter right here. That's at the top, 120 over kilogram. Okay. And then you got meters to the square over here, meters to the square. And this is going to be, what? Who's A? A is going to be 1 over 2. That's A. A is 1 over 2 over here. This is going to be A over here. Over here, you got your A is 1 over 2 meters. That's your amplitude. And this is going to be the square root of 45. And it's going to be meters over second. So that's going to be your answer right there. You got your answer here. It's 1 over 2 square root of 45 meters over second. And this would be the velocity at that point. So yeah, you can put it over here. So this is your answer right there. So you have calculated the velocity. So this is going to be 1 over 2. 1 over 2, the square root of 45 meters over second, right there. And yeah, your units are going to work because you got over here, you got joule over kilogram, and you got to get the square root of that. I'm just working out the units right here, these over here. And that's going to give you meter over second. If you do the work here, it's going to give you meter over second, and then you got your answer. Okay, thank you very much. And you have another problem about oscillations and energy. Oscillations and energy. Thank you. Bye.